Hello and welcome to Future Spaceflight and Earth's Threats, which is naturally accompanied by the reality of the necessity of Earth. My name is Jay Nguyen, and today we're going to be going over how Earth really is our only option in both the near and medium term future, and how it currently faces existential threats that are, for the most part, currently unabated. So let's start off by analyzing where humanity can go besides Earth just in general. And as it stands right now, there are only really two possible locations, and that is exoplanets and Mars. Now, first of all, Mars is a potential option simply because it is the nearest planet to Earth. It is also terrestrial. It is very common to hear Mars being talked about as a future location for human expansion. And there are also exoplanets. These can be really anything. And so naturally, they're a future place for expansion of humanity. Some places that are close like Mars but aren't even options are Venus because it is simply far too hot. It is essentially an inferno, as well as the moon because it has no atmosphere and very low gravity, both of which are problems of Mars that we will shortly get into. But the moon has them even more extreme. So moving on to exoplanets here. The nearest exoplanet, Proxima Centauri b, is 4.2 light years away. This is an extremely long distance. In order to create a comparison to make this understandable, this line represents the distance from Earth to Proxima Centauri b. And to represent the distance to Mars, I have simply placed nothing because there are not enough pixels on this screen to create an accurate representation. And according to the study here by Single and Single, with our current technology, it would take 17,000 years to create a return trip to Proxima Centauri b, and that is both the journey there and back, and that is using our current chemical fuel, which we currently do not have a proper alternative to. So it is simply a fact that right now, going to exoplanets is not something we can do. So there is the numerical term for this. It is 420,000 times farther from Earth than Mars is. But the real nail in the coffin for Proxima Centauri b, as well as other exoplanets right now, is that there is not even a guarantee that they'll be habitable. It's not even likely. And here we have a art's depiction of Proxima Centauri b. It really could be anything. And so moving on to Mars here. I said this earlier, but Mars is often thought to be by far the best location for humanity to go into the solar system because unlike exoplanets, it is actually reachable in the near future. So naturally, it is the logical place people think that would be a good place for humanity to colonize in the future. But the problem with Mars is that creating such a colonization is basically not even viable, and it probably never will be because Mars is just so different from Earth. There are too many aspects of it that stand in direct opposition to any possible colonization to the point where colonization efforts of Mars will likely only be small scale forever, basically. And here we have Mars as captured by New Hope orbiter, known for being a reddish orange hue. And so let's get into the specifics on Mars. So the first thing about Mars is that it is completely not breathable. It does have an atmosphere like Earth, but it is much, much thinner and is only 0.16% oxygen, according to the National Aeronautics and Space Administration. It is a simple fact as a result that it is not possible to live in the atmosphere of Mars without spacesuits. So the natural progression of this is that any potential habitation of Mars would have to be done entirely within structures. Naturally, this severely limits the colonization prospects of Mars, as essentially to go anywhere, you're going to have structures to go along with that, and that is also going to come with having to have things like power for the structures, the material to build them, and we had to keep in mind that all this stuff has to come from Earth in the first place. And so here we have just two graphs demonstrating the difference in atmospheric composition between Earth and Mars. Not only does Mars not have any oxygen, basically, but its composition is entirely different, with Earth being 3/4 nitrogen and 1/4 oxygen, while Mars is basically just CO2 in abundance with a few other trace gases. And so this is the main other aspect of Mars that will likely make it just completely not viable for long-term habitation on a grand scale. So to start off with, Mars's gravity is just 38% of that of Earth, according to NASA. And here is a graph showing that comparison. It is less than half. Here's a proportion. And this low gravity is extremely important to understand because basically all life on Earth is completely accustomed to living on Earth gravity. And so, as a result of this, multiple negative effects can happen to both animals and plants in low gravity. For instance, the immune system weakening and bacteria becoming hypervirulent, so becoming particularly prevalent, is extremely common, according to this study by Mermel. As well as this, water does not move properly in plants. This is, if you think about it, gravity is affecting the water in plants at all times, and they have essentially become accustomed to living with that gravity. And when that gravity is either taken away or is much lower, as is the case with Mars, it just does not work properly. And of course, this is a concern for us humans because we have a tendency to grow plants for food. And because of Mars's low gravity, that would be much more difficult. And the really important thing about this is that this cannot be solved. As of right now, we don't have a way to generate gravity. And even if we did, it would likely be quite resource intensive. So just to summarize here, Mars will never properly be habitable. And on the flip side, colonizing an exoplanet would just take such a level of technology that we will not have it in the near or medium term future. We're talking on the scale of thousands of years, at least, probably. And so the main conclusion here is that for the foreseeable future, essentially, Earth is humanity's only problem. And this is where we lead into why we're talking about this, how this is a problem. Because the future of Earth is not good right now. Due to global pollution and climate change, basically, Earth is on a timer. It is estimated that by the end of the 21st century, the equatorial region, so the areas around the center of the Earth, where it's the most hot, will be completely uninhabitable at the current rate that our planet is warming by. And so here is a graph demonstrating the historical pollution data of G20 countries. These are the 20 countries that are generally considered to be the most powerful, the most economically powerful. And as you can see, it's essentially just either staying the same or going up. So there's no going down there. And that is according to the report by Schramek and Harmling in 2017. And so here's another graph that just shows the result of the previous graph I just showed you. As the pollution increases and as it's not abated in any way, the temperature increases as well. And as you can see, it is quite a significant climb. It is essentially a linear upwards climb that is completely not stopping at all. And this has been occurring since 1980. So in short, Earth is on a timer, but not just a timer, a brief timer, extremely brief timer, and it is surely much, much, much shorter, this timer is, than how long it would take humanity to properly leave Earth. And so we're only left with one option. We have to fix the existential threats that Earth faces, or there will straight up be no future generations for any of us. And so what are these solutions? Well, they're quite simple, really. The main thing we need to solve here is pollution, climate change. And so one way we do that is the utilization of renewable energy sources. This is the natural first step. This also leads into the reduction of fossil fuels. So you have the combination of energy sources that do not pollute the environment and the fact that they're replacing fossil fuels that do. And so another thing of this is utilizing more energy efficient electronics, just using less energy in general. An example of this is using LED bulbs instead of incandescent bulbs, as they are significantly more energy efficient. If you're using less energy, then there's less energy that needs to be produced. Green energy sources that produce less energy at a certain given time than fossil fuels can become more viable as there isn't such an extreme demand of energy. And so one of these main ways to quantify these solutions is making sure that global temperatures do not rise above 1.5 degrees over the pre-industrial temperature. So these are the temperatures that was mainly stable before the Industrial Revolution happened and pollution began. So we're left with the question of how this can be done. And really, the only option is legislation. Laws have to be created, not just created, but also on a global scale if climate change is to actually be mitigated. And those laws actually have to be properly enforced. And so, just digging into specifics of legislation here, one of the potential ways that legislation can deal with pollution is requiring green energy to be used in place of fossil fuels. So that's a hard requirement. That's you have to use green energy instead of fossil fuels, and a good way to achieve this, as an example here, is to give subsidies to green energy companies so that they can be more economically viable. As a lot of the reasons that green energy isn't used is economic, it is simply more profitable to burn fossil fuels to generate energy than it is to do green energy. And so, to go along with that, certain laws will need to be made to target these emission targets we've set, such as the aforementioned 1.5-degree target being achieved. So, an example of how to achieve this links back to the previous point, and that is just fines on companies that do not comply with emission regulations. Again, this has to essentially be, they have to actually be enforced, because if you make laws and you don't enforce them, they basically serve no purpose. And so here are all my references used throughout the presentation. And that would be the end of my presentation. Thank you for watching my presentation. It is quite an important topic, I believe, considering, well, humanity won't exist in the future if there isn't something done about it. So I hope I have allowed you to learn more about how our future prospects in space really aren't that great right now, and our only option, Earth, we're currently destroying. So we need to do something about it. That's the thing I want you to come away with. Thank you.